Hello, everyone, and welcome to today's SANS webcast, Securing Your Hybrid Data Center, sponsored by Palo Alto Networks. My name is Carol Auth of SANS, and I will be moderating today's webcast. Today's featured speakers are Dave Shackelford, SANS Analyst and CEO of Voodoo Security, and Krister Swartz, Consulting Engineer at Palo Alto Networks. And with that, I'd like to hand the webcast over to Dave.
Great, thanks Carol, and thanks everybody for joining us today. It's always exciting to be here with the folks from Palo Alto, getting to talk about the things that are happening out there in the industry and really what's changing with regard to security as well. And so, of course, I think just by the title of this webcast, we can all figure out that we're talking about a hybrid data center. But what does that really mean? And actually, what does that sort of bring about in the world of security overall? And there's just so much to actually talk about and cover there that what I really would like to do is actually, can you give me keyboard and mouse? So it's me and it's Krister. And so I'm just going to have a brief introduction about this where, really all I'm suggesting is that this almost is changing everything we've done in the past. And so some of the same concepts apply. We're dealing with things like network security. We're focused on operations and monitoring and all of the traditional concepts and categories of security that we've traditionally relied upon. But the nature tactically of how those are being implemented is radically shifting. And that's largely due to this, sort of hybrid strategy that most are adopting as we shift from, kind of core, sort of encapsulated data centers and move out towards these hybrid connected models to different types of cloud services. And so we've definitely got to make sure that security is on board with those changes and what that constitutes. But what I'd like to do is bring in some sort of background just from some of the results of our cloud security survey, because we got a lot of feedback from the community as to what's really being seen out there in the realm of security for hybrid strategies. And I think it's relevant to many of the things that Krister will also talk about as far as, what Palo Alto is doing and what they're seeing their customers do as they're realizing some of the technology stacks that we've relied on, again, maybe don't work quite as well or have to be adjusted to work differently as we move towards that hybrid model. So let's go to the next slide. And this is a simple one, right? I mean, I think if you take a look at the traditional data center, we've had that sort of classic perimeterized model in place forever. And while it's easy to say, well, the perimeter is dead, it's not really dead. We've just changed to having multiple layers of perimeter. So even though this is a simplistic diagram, and that's on purpose, what that's showing you is that, yes, there's a data center, and yes, we might have had a traditional, say, network firewall at that perimeter, protecting us from things coming from the internet. Even internally for the past 10 years or so, as people have built converged infrastructure and maybe even private clouds, we've seen a degree of internalized perimeter as well. So where you see all those little VMware sort of stacks inside, well, there's perimeters embedded there too. So you really already have multiple layers of perimeter. But the question then becomes, well, how do I shift that out? So if you go to the next slide, I think all I'm trying to depict here is the fact that, well, we've got to try to take some of these things with us as we move out, but some of the technologies we're adopting and starting to implement for orchestration and automation, starting to use containers instead of just virtual machines, and also leveraging highly complex technology stacks like even Pivotal, Cloud Foundry, and starting to have to create multi-cloud connectivity platforms and environments. And again, there's some just generic things strewn about on the slide. How do we take things like that perimeter firewall and turn it into more of a hybrid mesh firewall model that we can adapt to our cloud strategy? And so this is a pretty good depiction of the kind of thing you can end up with as your organization starts moving out towards cloud and creating this hybrid connectivity strategy. You've got to start thinking about this. So let's take a look at some of the things that we've had the community come back to us and say that they've seen over the past couple of years. So let's go to the next slide. So I cherry picked some data and we've got a lot of really interesting results that came back in from the survey this year, and it's all posted for free online on the SANS site. So any of you guys can go get the full survey results if you want to, but I think some of these are more relevant than others as far as this discussion particularly. And of course, top of mind for anyone that's looking at moving to the cloud or starting to deploy into the cloud, and thus again, creating a hybrid data center architecture and sort of operating model. The big thing is, has there been some increase in breaches as people are moving out to the cloud? What are they actually seeing out there? And so of course we asked that question. And as you can see, a lot of people said, well, yeah, probably not. And that's, maybe hedging your bets a little bit, but arguably what you have here is about 10% or so saying, yeah, we've certainly seen some actual breaches in our cloud environment. We have some that said, yeah, we think so, but we're not 100% sure. And then a few that said unknown. And really, if you aggregate those together, you've got just under 30% that very likely have experienced something. Some of them don't know exactly what it is, or maybe just don't have the degree of visibility they need to know what it is. But my guess is there's probably been more activity in those cloud environments or between the on-premise and cloud environments than people realize. And much of that might be due to some immaturity or lack of technology or both in the types of tools and services and processes that have been enacted to sort of bring our hybrid strategy up to speed. So let's go to the next slide, where I'll actually break down what happened. So of course, any of these folks that said, yeah, we have had an issue, or we think we might have had an issue, the logical follow-up question is, well, what did that actually entail? What types of things actually occurred during said breach or incident? And I don't think it'll probably come as a shock to any of you guys that right at the top of the list was account hijacking or the use of credentials. But what this really is intended to show you, I don't want to sort of belabor this and have a big, long, drawn-out discussion about every possible thing that could go wrong in the cloud, but it's the classic stuff. It's misconfiguration. It's things like user abuse for privileges or just account hijacking. It's unauthorized compute instances or components. People are spinning up stuff that we shouldn't be. Insecure APIs. Shadow IT. It's all these kinds of things. Denial of service attacks. Sure. Here's the thing I sort of wanted to illustrate, I think, with this. These are problems we already know about, right? These are the same kinds of issues, maybe with the exception of APIs or something that's very cloud-centric. We know about most of our attacks primarily being due to users and user accounts in some way, shape, or form, whether it's through phishing attacks, whether it's through something else that hijacks endpoints, etc. So that's not new. That's not necessarily something that, again, we could say, wow, that's completely, something only as a result of cloud are we seeing this. No, I think it's much more to do with just more assets and more technology distributed in ways that we're not really monitoring as well as we should or protecting as well as we should. So I look at this set of results in terms of what was involved in these attacks, and to me, what stands out is that many of them are things that we've been dealing with for some period of time. We're just not really solving the problems well for hybrid types of strategies or hybrid types of deployments. So let's go to the next slide. And so I also wanted to try to find out what cloud controls people were using. And again, this ties into, that hybrid technology stack, because we've got a lot of controls on premise or have had a lot of controls on premise. The real question is, which ones are we able to take with us as we move out into public cloud environments? And, can we use the same tools? Do we need different tools? Are we using service-oriented models, or are we, still traditionally managing things from on-premise or internally? What's the breakdown of this? And I think you can clearly see that there's a few technologies that we're, really still putting in place within the cloud. Things like anti-malware and VPNs and, things like multi-factor log and event management, vulnerability scanning, network access controls. That group is pretty prevalent. I mean, you're pretty close to about 80% of organizations feeling like they're sort of moving in that direction. but the vast majority are still using internally managed models for this, or to some degree both. And only a small percentage have started moving towards security as a service offerings or more sort of provider-oriented offerings in a cloud-native format. So I think that is actually very telling. Most organizations are really trying to keep up with the management of their core security controls from their on-premise teams and processes. And sometimes that works pretty well, and maybe in some cases it really doesn't work as well. We're certainly seeing some shifts that are happening there, but nonetheless, those are the technologies that people really do seem to be, at least based on the responses that we got, moving out fairly well into the cloud with. Let's go to the next slide. And we also wanted to see just what those controls integration scenarios looked like. And so, we looked at this and said, hey, look, 50% feel like they've got, integrated network access controls. About 47% have network traffic analysis. Those aren't great numbers. I mean, again, it's nice that we've got half that are coming back and saying they feel pretty comfortable with that. And, about 45% have integrated things like their SIM. But we really, at this stage, it's 2019. I had hoped we would see a larger number feeling comfortable with a full stack of controls integration across internal and public cloud scenarios. A lot of people said, well, we've got some future plans here. Again, more event management, more forensics and incident response, more endpoint detection and response. Those are all things that are on the docket or on the roadmap for, some of the organizations going forward. But it's particularly discouraging to see that maybe roughly half of the folks that came back and sort of said, hey, we're starting to integrate. Network controls are core to a security strategy, and I think it's probably very difficult to affect a strong hybrid cloud architecture security-wise without those. And only half, or roughly half, have gotten to that point. So I think we've got a lot of improvement to do there. Let's go to the next slide. And this just breaks down the full list of those things. So I wanted to, again, pull out a couple of those pieces and sort of demonstrate that. But you can see some of these are even far below that. Most organizations really haven't gotten to things like DLP. They really haven't gotten to a lot of the endpoint and forensics types of tools. We have seen some intrusion detection actually get integrated. We've seen some, network traffic analysis. We've got a few pieces moving in the right direction, with the biggest being things like multi-factor authentication, which I won't say is easy. It can certainly be a headache too, but that's something that many of the cloud providers natively offer that integration with. And so it's not too hard to sort of tap into that. And certainly for privileged users and administration, anybody would want to do that. But some of the other more on-premise oriented control sets, again, vulnerability scanning, things like anti-malware, and certainly almost the entire gamut of network-based traffic control and inspection, we've definitely got some growth that needs to happen. Let's go to the next slide. One of the things I always encourage people to do as they start moving into cloud scenarios is sort of take a step back and reevaluate the vendors and the providers that they've been working with. And that's not to say that this isn't a good idea irrespective of moving into cloud. I think it's a good idea anyway, because you should be looking at the different tools and technologies that you've got to make sure that they're working well for you and that they're meeting your requirements from a business standpoint. But in particular, when you move out into cloud, ideally, if you've got trusted partners that you're relying on right now for a variety of technology areas, they can go with you and sort of make the journey with you. And, in particular, as you move into multi-cloud types of deployments, this becomes even more critical. And so that's why we sort of ask the question, do you have some of these things currently, or are you planning to try to, really find that single vendor option in the next 12 months or so? And the good news is we've got, again, close to 50% saying that they currently do have a set of trusted partners or vendors that they're working with that they feel like they can take with them into a hybrid model. And, anti-malware was right up at the top. Vulnerability scanning was right up at the top. Network traffic analysis was pretty close to that too. So that was another one of the high ones. Again, multi-factor authentication, IDS, IPS, network access controls, those were still pretty close to the top of the list. And so I think there's a direct correlation between this set of results with the single vendor options and the past slide or set of slides where we looked at that controls integration. What that tells you is that people want to manage things from on-premise, and probably plan to continue doing so. And they're heavily prioritizing those partners that offer the hybrid types of technology capabilities. So let's go to the next slide. I won't spend a lot of time on automation and orchestration. I think there's, a lot to be said here. But I do want to find out, of course, whether people are leveraging automation and orchestration technologies as they move to cloud environments. And sure enough, people are starting to. And you see that infrastructure as code, the template type technologies like Terraform and CloudFormation, et cetera, those are certainly growing, and a lot of that's being driven by DevOps teams. What we're also seeing is a significant area of growth in configuration orchestration for lots of our platforms, as well as some security orchestration and automation and response as well. So there's a whole category of tools and integration with these tools to facilitate more rapid fire detection and response capabilities. And integration is sort of the key word here, because if I have certain types of events, maybe I can automatically open a response ticket, or I could perform some sort of evidence capture, or even do an automated quarantine for users or what have you. Lots of use cases you could come up with there. But what you have in the cloud, and this is definitely a big shift from on-premise, is a whole software-defined infrastructure that can maybe facilitate this through the use of APIs and things more extensively and accessibly. So lots of positivity here, actually, lots of really good things that I think are developing. So let's go to the next slide. And I'll just start sort of wrapping up here by saying, look, there's a lot of things I think security teams need to be, considering top of mind, and automation and integration are the biggest ones in many ways. Things like automating your static code analysis or application scanning in a DevOps pipeline, having automated checks for server workloads, container workloads, things like your network configurations, especially if they're software defined as well, having monitoring across the entire environment as well as in the cloud. So what I also tell folks is, look, you got to really separate your classic asset model, so servers and other workloads, from the actual software defined fabric of the environment, the AWSs and the Azures. They both have configurations. They both have potential vulnerabilities. They both have a number of things to explore, and you've got to have tools available to you that can do both, ideally. And, finding one tool to rule them all may or may not be possible, but definitely looking for both of those in parallel, having hybrid controls to be able to implement ideally in single vendor formats where possible and where it makes sense. And then also ensuring that we've got tools for things like forensic data collection, investigations, and conversion environments too, has really been a struggle. And a lot of organizations are still playing catch up here, trying to find ways to integrate that across the board. Let's go to the next slide. And what I'll do is just wrap up my section here and say, look, as the hybrid model grows, and it definitely is growing, and I think this is probably the model we'll see being implemented for the foreseeable future, some of the key things for security, we're not going to get there without some degree of automation. I can tell you that. You don't have to automate everything necessarily, but some is going to have to happen. We need better integration with workloads, and that means compatibility across different environments, centralized controls, and environment monitoring in the infrastructure and platform services, behavioral monitoring. I could keep going, right? There's a lot of things that I think we're having to, implement sort of net new, but also just shift what we have been doing to sort of hook into the provider environments that we're connecting to in the first place. And I know Krister has lots of things to say about this. So Krister, take it away.
Okay, so digging one level deeper from this, there are three priorities that need to be kept in mind with this. Security, network security in data centers has remained pretty much stable or static for the last 20 years or so, but it's now undergoing a pretty major evolution. And the three details are this. We've moved now from the big data world to the fast data world. which means a security that relies on humans to interact in any kind of threat scenario is just going to slow things down. So we need to have fast response, fast security response to fast data. And this incorporates things like virtualization, software-defined networking, and hyperconverged everything. We need to have security be able to follow this model. Also, the whole DevOps direction means that the traditional distinctions between the developers and the data center operations teams has really disappeared. So the continuous integration and deployment to microservices and APIs means that we can no longer have a distinction between network security and system security and things. We have to have some kind of holistic approach across all of this so that wherever your workloads are is where the security boundaries are. So that you mentioned that boundaries are disappearing. Maybe they're really just evolving, but we need to basically say that where the workload is your perimeter. And the ultimate goal here is a hybrid cloud. So the idea is to have one giant fabric across your data center, across some kind of public cloud service, and workloads can migrate back and forth. IP addresses will change. So we have to move away from a traditional approach where security is only paying attention to IP addresses, assuming that workloads don't move. So the main point that we point out here is that in any data center, most of the traffic is server to server. So for every packet that comes in through the front door, through the north-south direction, this will trigger a lot of associated traffic, server to server, VM to VM, workload to workload within your data center. And so this means if you follow the traditional perimeter approach, you're going to be blind to the vast majority of your traffic. So we have to somehow push security deeper into the data center, yet without adding more complexity to an already complex network fabric. So what we need, the ultimate goal here is we want deep visibility. Every data center has a firewall of some kind, but most traditional firewalls are only looking at the ports and they're looking at the IPs. And looking any deeper usually slows things down, so the data payload is not really inspected. We need full layer 7 visibility into everything that packet is associated with, what it's carrying, what the application is, and who owns it. We also need to create a segmentation solution. A lot of data centers are flat, so once you're in the data center, largely it's you'll see one giant VLAN or maybe only a few subnets. And if you can get malware on any of those hosts, they have free reign everywhere. So we need to create some kind of segmentation. And this can be traditional segments, like adding more VLANs, more subnets. Different vendors have different approaches to micro segmentation or macro segmentation. Somehow reducing the attack surface. So if malware does infect something, we can reduce the damage that it can do elsewhere. And then automated threat protection is really probably the main priority here, because malware is extremely dynamic. It's command and control oriented. It morphs, it changes, almost like a cold virus. And the traditional intrusion detection approach just won't work. If something bad happens and your system sends you an email and waits for you to do something, it's too late. So the security posture has to immediately react in real time as these modern threats hit your data center. Now, with Palo Alto, we have really two approaches to delivering inline firewall security. So we have hardware platform, we have virtualized platform. They're really pretty much equal across the board. We have small things, we have big things. The main difference is that the virtualized appliances are, the performance is really dependent on whatever you deploy us on. So our hardware firewalls, our virtual firewalls are running the exact same OS, which is a point we often stress, that if you have multiple vendors in the data center and you have, say, that same vendor has a virtualized appliance in a cloud environment, often the feature sets are not the same. Features sometimes have to be removed on a virtualized platform to improve performance. That's not the case here. So when you deploy our firewalls, whether virtual or hardware, when you manage them, you no longer have to worry about the footprint. It's the exact same OS. The middle box here shows that all SDN solutions in data centers are controller-based. So there's some kind of controller, some kind of central brain making decisions about how the network is built and how migration happens and how overlay networks are built. And all of that complexity is what we want to avoid interfering in. So we want to do security by talking to the controller. So we want to exchange useful information with that controller about what traffic is inspected and what is bypassed. So Panorama is our management platform, and regardless of what kind of firewall you put in place, that is talking to the controller. And this is also the case with the far right box with the public cloud. There's a controller in each of these as well. So the traditional networking approach is very much involved in the network fabric itself, but everything now involves some kind of controller, and security needs to interact with that. Your data can reside on an endpoint device in either a private cloud or in a public cloud, and this can reside on the data center. We want to be able to inspect traffic everywhere, so we also have the ability to look at endpoints. We have the ability to look at SD-WAN solutions. Anywhere your data can move around and anywhere it can reside needs to be looked in at one holistic approach. So wherever you place our security in these three circles, we also act sort of like probes. We're also collecting a lot of useful information because malware is changing constantly. So we are both inspecting at these points and also harvesting behavior information from these points so that our larger behavioral analytics solution is aware of any problem from any device, pretty much anywhere around the world in real time. So deep visibility. What that means is, really to kind of reiterate, we want to have complete knowledge of what exactly is being exchanged between our data centers. I sometimes have spoken to some CTOs who say they can't sleep at night because they don't know what's in their data center. And then after we show them, they say, well, now they can't sleep at night because they do want to know what's running in their data center. So the deep visibility can give you information that is useful or frightening. But we want to be able to segment these out according to business divisions, and in this case, it could be users or applications or specific divisions, and also along branches and campuses and WAN separations. But we want to be able to apply zero trust across all of these. And one aspect of the zero trust guideline is to push security as close to the source of traffic as possible. So step one in the life of any packet should be policy. Packet is born, a firewall somehow inspects that traffic, and only then can that packet go any further as we segment our environment. We also want to be able to manage this from one place. So a lot of these solutions involve what's often called a swivel chair problem, because you have different portals looking at different things. So you have a portal for the IDS solution, a portal for your malware, a portal for the URL filtering, a portal for your firewall. And this is often hard to correlate back and forth during a threat incident. So we want one place. So Panorama is our central management plane where we can manage several thousand firewall points everywhere. And some of our interface looks a bit like Splunk, and it's all in one place. The goal is that when you manage this, you want to be able to see everything and correlate events in real time from one window. As you drill down, you can get an idea of what exactly is going on. You can look at application dependencies, what users are doing what. We also want to be able to see traditional network maps. So ultimately, no matter how much we talk about cloud, there are traditional networks underlying all of this. So we want to be able to see what tunneling is going on, what routing protocols are being used. And a lot of the controllers in SDN architectures are using metadata. They're actually applying metadata to workloads, which remains consistent as they migrate. And we need to pay attention to that. High availability, these are traditional networking concerns, and firewalls have to still be able to support the traditional networking priorities, but also be aware of what's going on in the more cloudified future. And then we want to be able to apply really a blacklist model. We want to apply a whitelist model. So we want to be able to allow only what is allowed and deny everything else. And this is usually the opposite of traditional approaches. Many customers will have an idea of what's bad. They'll blacklist that and allow everything else. We want to be able to whitelist and assume we don't know what those bad things are out there. So segmentation. Again, this is a big topic with many legacy data centers because there is none. There might be one flat network, maybe a DMZ, and a front door to the internet, and that's it. But maybe they failed an audit, or they understand the priority here. But how do I do this? How do I segment my network? And one is the traditional answer, which is I have my north-south perimeter, and that might be a NAT boundary. And inside my data center, I'll create some kind of division between hosts. So maybe these are my database hosts, and these are my web hosts. And I will create some VLANs between them. And then I can use that to reduce the attack surface. We can further go down this layer of segmentation, both across public cloud and private. In public cloud, we're creating VNets or VPCs, which are, from a network perspective, functioning similar to network segmentation. This works, but it is a bit labor intensive because re-IPing a data center involves a lot of work. So there are other approaches to doing segmentation. Now, realize that the perimeter is always going to be there. So the perimeter is not dead, the perimeter is always alive. It's just really the first point of enforcement. East-West fabric is creating segmentations that are really agnostic to VLANs and subnets. So Cisco has the idea of an endpoint group. A macro segment is an Arista term. A lot of these use VXLAN to build overlays. So the network topology is actually in this tunneled VXLAN topology and not down at the hardware. And this allows you to create segments sort of above your traditional network without re-architecting the network itself. And this is largely done from a systems level perspective. So this allows you to become as granular as you want, rely either on port groups or microsegment all the way down to the containerized layer. You have a lot of options. How do you do security with this? As you create all of these segments, how are we actually paying attention to what's going on? So this is another way of visualizing the Palo Alto's full product line. These are the ones you'll see in the data center. There actually are additional firewalls, but starting with the one on the left and all the way up to the chassis model on the right, this is generally what data centers will deploy. And the VM series are generally used by customers whose priority is speed of deployment. If you need to add new firewalls for scaling out or pulling out firewalls, it's usually quicker to deploy software equivalents than to rack mount hardware. We give you the choice. Again, it's a single OS, so you're not losing any functionality. It's really just more of a choice of what kind of footprint you want. Now, segmentation is something that we stress a lot because ultimately a firewall needs to keep track of an untrusted segment and a trusted segment. And we sit in the middle and we are enforcing access between these segments. And there are different ways of thinking about this. So one that all firewalls use is zones. And this really is just a collection of IPs. So these IPs are untrusted and those IPs are trusted, and I will sit between them. But we can also segment based on something like a user ID. So we don't know where you're going to connect into our data center. So we will just look at Active Directory or Radius when we see traffic and ask, what segment did this belong to? And then we can write policy based on user ID. We can write segments based on what kind of applications are contained inside the packet. Global Protect is a VPN solution, all the way down to really what's probably the most important in a data center, and that's this idea of dynamic address groups. And this is the ability to write policy that is not specific to IP addresses. And this is a point we often stress, because if you build a hybrid cloud where you have a private data center and some public cloud, and you envision your workloads moving back and forth, those IPs will change. And in a traditional firewall, every time the IP address changes, you have to touch the firewall. And if you follow that model, it's going to be very difficult to scale because there's going to be a lot of churn on the firewall that is constantly updated. So how do we not do that? So this is a little piece of our GUI showing what this concept is. And this is called tagging, or it's called metadata. But it's sometimes sort of like an empty bucket. You go to the SDN controller and you decide you have some tagging information that's useful to you. Like I have web servers, I have app servers, I have database servers. Those are just names. So on our firewall, we create those same names. So in this example, there's a little thing called map server. We plug this into a rule. There are 0 IP addresses in this. Initially, this does nothing. But it's a bucket because the SDN controller can spin up VMs, assign IPs to some tags, and then it'll send that information to us and say, okay, for that tag that you have, I have 5 IPs that are currently assigned to that. So if you see these IPs, trigger this rule. And if it spins out those VMs, it'll do the opposite. It'll reach out to the firewall and say, clean out those IPs. So you avoid the problem of having these legacy rules with hundreds of rules where nobody knows what they do and nobody's willing to remove them. So one way of visualizing it is this way. If this box represents the SDN controller of choice, this could be ACI, VMware, could be an OpenStack solution. In the bottom, we have 2 workloads, and each one is tagged, here with 1 tag each. A record is built, so each VM has a name, an IP address, some information about what's running on it, and these tags. The APIs means that this represents panorama. So on our side, we are getting a complete record of what's going on the controller. And as IPs are mapped to these names, that information is now pushed out to us. So on this right-hand column, we now have IPs that are associated to these names, to these tags. Firewalls have traditionally always written their rules along this right-hand column. At the end of the day, the rules are going to say this IP can talk to that IP. But we want to write rules based on the left-hand column. So if this box represents any of our firewalls, we can write rules that essentially look like a human sentence. So it can say my SharePoint servers can speak to a Linux web server, but my SQL servers are not allowed to talk to Miami. There's no IPs here in the rule. The IPs are tracked in the background, but the rules now are written in a way that mirrors the way users perceive the resources. And this is usually how they'll report problems, by the way. They're usually going to say, hey, my SQL servers have lost contact to Miami. The first question, of course, is what's the IP? What's the port? Nobody knows. It just delays troubleshooting. But this allows you to write rules that reflect how users perceive it. And you can click through immediately and find the IPs, and troubleshooting is made much quicker. And over here in the white space, if a new VM is spun up, a tag is assigned, an IP is assigned. Over here on our side, though, we're already tracking this tag. So the new IP is added in the background, but we do not have to update the firewall. What this means is you can write your policy once, and then as you scale out your data center or your hybrid cloud environment, you do not need to touch the firewalls. The firewalls are stable. And so this removes a huge operational headache with the traditional change control and constantly playing with the firewall. So this is a way of applying policy based on metadata, because this tagging remains consistent as workloads vMotion or migrate between hosts or clouds. The IPs change, the tagging does not. And we want to be able to write rules based on the tag. So this allows us to essentially virtualize security along with everything else. So quickly, these are two vendor examples of how they do that. Cisco ACI this is Cisco's approach to SDN, and it's a very network-centric approach to building an overlay network. So in this example, it shows that ACI requires that you build your physical topology according to this so-called spine leaf model, where I have some high-speed backbone switches and a lot of leaf switches. APIC is their controller, which manages this environment. And here you can create your concepts, your entities. I have my web entities, my app, and my databases. And Cisco calls these endpoint groups or EPGs. And we want to somehow insert our firewall in between these in a logical perspective. We don't want to place a lot of firewalls in the data center. So what happens is Panorama manages this environment. And physically, you'll have the physical firewalls deployed on one of these switches, but logically, Panorama is communicating with the APIC and saying, steer traffic to me, and we will logically place packets through the Palo Alto firewall between these endpoint groups. So from a logical perspective, as a packet moves from one to the other, it's passing through us in sort of a service chain using what Cisco calls a contract. So ACI introduces a lot of new terms, but at the end of the day, we are a service chain. As packets move from point A to point B, they are steered to us. Now, there are two broad ways of dealing with ACI. There's managed mode and there's unmanaged mode. Managed mode was the original idea with Cisco's ACI, and this is the idea that the Cisco controller will control all of the Cisco gear plus all third-party gear. So you, the third party, write a plugin with your APIs, plug that plugin into Cisco's controller, and it will now reach out and configure Palo Alto along with Cisco. Cisco no longer recommends this. This didn't really play out the way they'd intended, so they now have what they call unmanaged mode, which only means that they will not manage third-party devices. So you deploy Palo Alto firewalls into the fabric, and you manage Palo Alto the way you normally do with Panorama. You manage Cisco using their APIC, so they're not managing each other. But we do want to get that information from the controller regarding what IPs are assigned to which of these tags. And that's what this gear represents. We have a plug-in into Panorama, which at regular intervals will ask Cisco, hey, do you have any updates? I have these tags. Do you have new IPs? Have you freed them up? Just give me the information. So instead of pushing that to us, we pull it. So we're largely agnostic to software revisions and upgrades within Cisco. We're sitting in the fabric, but we're not adding any complexity whatsoever to the fabric as you scale it out. NSX is a similar approach, but this is more of a systems level way of doing much the same thing. At the end of the day, Cisco here is building an overlay, VXLAN overlay from the network up. But with NSX, they're doing much the same thing, but from the systems layer down. So again, they have their own concept of segmenting workloads. They call it security groups. Their controller is basically pushing the network edge up into the hypervisor, creating the VXLAN tunnels there. In this case, our firewalls are actually deployed in the hypervisor, in NSXV. In NSXT, we are deployed at their virtual routers. But we're actually we're essentially present within the host itself. With Cisco ACI, we're present in the network, and with both flavors of NSX, we're present in the host. And we are seeing traffic before packets ever reach the core. So this is another advent of zero trust. We want to push our solution as close to the birth of a packet as possible. So we can have Panorama manage a firewall in each of these environments, and we can enforce the security either north-south in and out of the host or between tenants. So again, this is similar to ACI, but we are agnostic to either one because from our perspective, there's a controller in either place. So Cisco has a controller, NSX has a controller. Panorama will talk to each one. You have to decide who is running what workload, but at the end of the day, we can be deployed in either environment or if both are somehow combined together. Now, once you do all this, this is often what's called plumbing. We now are plugged into the environment, we're plugged into the plumbing. Now, how do we avoid the common problem where firewalls are just an extreme mess to look through? Because most people, when they print out a firewall rule set, they have no idea what half of it does, but nobody's willing to touch it because you might break something. So how do you simplify this? So we have something called Policy Optimizer. And this allows you to take your existing firewall rule set, whether it's a different vendor or one of our older firewalls, and you can feed it through basically a decision engine, which will take a lot of rules that are perhaps specific to IPs and ports, and we will identify these ports as actually belonging to one application or several applications that are dependent on each other. And we will reduce, say, 10 rules down to one. I've seen several cases where you have thousands of rules that are reduced to hundreds of rules. And these rules now we're paying attention to applications, the data payload, and not just ports. So this means that we can look at the data payload and come up with much simpler rules, ones that are much easier to navigate through rather than the old policy mess that we had before. So this allows us to create app ID focused rules. The rules are specific to what's actually going on in the packet rather than just trusting the headers and the ports, which produces the firewall configuration nightmare. Finally, automated threat protection. We need to respond to threats in an automated way. Once you plug everything in and once you simplify your rules, what actually are we doing with that packet? As we receive a packet in our firewall, we need to instantly be able to react to threats that we know about, but more importantly, threats we don't know about. So threat prevention really is about tying into our service that we call Cortex or Wildfire. And these are cloud-hosted services where we're really talking to all of our firewalls around the world. So if there's some kind of threat that's appeared in Australia this morning, that information through Wildfire will be pushed out to all our firewalls around the world. Traps is our endpoint solution. Network firewalls are looking at traffic that's in motion, but a lot of threat actually happens on data that's resident on the endpoint before it's even moved. So Traps is our ability to analyze stuff that way, and Traps and our firewall all feed up into Wildfire and Cortex. And this allows immediate response. So if we see bad behavior that doesn't match any of our signatures, we feed that up to Wildfire and Cortex, and within minutes, it will analyze the behavior and immediately return a response to either block or quarantine these workloads. Wildfire is the zero-day protection service that we have. So all of our products will receive updates. From that first example of malware appears in Australia, and within minutes we push that down to all of our products everywhere. But you can also choose some of your data to be pushed up into Wildfire in an anonymized fashion to add to that data lake or that resource of information for how malware behaves. And we can do bare metal analysis and VM, and this has all the usual buzzwords: machine learning, AI. It just really means that we're watching behaviors. We can't possibly know about every single signature, so we're looking for behavior. And malware tends to behave in ways that are often predictable, and this allows us to immediately react to that without putting a human into the process. Traps, again, is our endpoint, which we can put on a number of devices. Up at the top here, Traps is managed from the cloud, Wildfire's in the cloud. A lot of these things are just hosted up in the cloud. So that's really the management portal. So as you deploy these network solutions on your devices, they are managed from one central location in the public cloud. So again, we're sort of reiterating some of this. The basic theme is get humans out of the picture. We need to immediately, since malware transforms dynamically, security response needs to be equally dynamic, and humans are slow. So we need to have an API-driven solution that is instant, and then we're notified about it after the fact, but it's not, we're no longer the bottleneck. So Again, this is reiterating some of these facts. We want to be able to identify users. We want to identify, we also want to be able to make sure that custom developed software is not interpreted as a threat. So you do have the ability to, if you've developed your own code, we can learn what that is and add that to our whitelist. So this avoids you developing code and immediately having it blocked because we think it's malware. And we want to be able to detect things like data exfiltration. Ransomware is a big problem. Again, these are things that are these happen way too quickly for humans to enter into the picture. So if we zoom back out again from all those details, what we really need to do to secure all this is to have one approach to prevent bad things from happening before you know about it. Okay, we need to do it in an automated fashion. We need to respond and adapt instantly. And we need to be able to then quarantine data and then allow you to do root cause analysis to figure out what went wrong and to prevent that from happening again. So I'm going to stop there. This is kind of a long, detailed way of saying that you need to have one security posture that analyzes a lot of threats beyond the traditional port-based perimeter firewall.
All right, thank you so much. We do have a question that is begging to be asked. Where should I begin in terms of deploying security for my data center?
So that is a common question, and I usually take into account who's asking it. So if it's a networking team, they're going to be thinking in terms of network firewalls. If they are a systems team, say a VMware admin, they're going to be asking more about host level security. What I recommend is obviously go to paloaltonetworks.com and contact the appropriate group, because you're probably going to want both kinds of solutions. You're going to want both a network solution and some kind of a systems level solution, but these should be tied together. So I would recommend contacting us, focusing on the whole zero trust philosophy, which will allow you to answer that question without adding another layer of complexity, because most people are really hesitant about security because it's just one more headache. And if you first decide whether you're talking about a systems level solution or a network level solution, start there and then make sure that you tie both solutions together in the end. But again, go to Palo Alto and remember the term zero trust.
All right, well, thank you so much, Dave and Krister, for your great presentation, and to Palo Alto Networks for sponsoring this webcast, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.